Okay, we're back. We are on page 3 of notes 4 of Calc AB. I really want to say page, I don't even know. I want to say we're on note 6 because I keep seeing that there are 6 pages in these notes and like going for that. Whatever. All right. So we're going to start with a question, and it says, graph of g of x is shown. So this is a graph of g, not g prime. G prime and f prime, first derivative, most common graph that you will be given, but not in this case. Graph of g of x is shown to the right. Show that g of x is not differentiable at x equals 4. Okay, how are we going to do that? Use the alternate definition. So in my mind, the alternate definition is the one where its limit as x approaches a, because the limit, the h one is just so much more common. Use the alternate definition and one-sided limits. Okay, let's go for it. So, I mean, you can see visually this thing is not differentiable. If that were a roller coaster, you're in for a very bad time when you get to x equals 4. And that's basically how you can see that a function is not differentiable. Sharp turns, definitely not differentiable. All right, so we know it's not, but, and the problem says that it's not. So what I'm gonna do is I'm gonna say that the limit as x approaches 4 from the left of f of x minus f of 4 over x minus 4. So what can we do? I mean, it looks like this thing is quadratic, but we don't actually know that. Also, we don't have to be like super fancy on this, right? So if we're to the left of 4, then we're on this part here. And you can see that as x approaches 4 from the left, the slope is definitely negative. So I'm just going to say here is less than 0. Because it's kind of really the best I could do. I could write the equation quadratic, but like, do I actually know that it's quadratic? Not really. But I definitely know that that limit as x approaches 4 from the left, f of x minus f of 4 over x minus 4, definitely negative. Okay, and we're in luck because the other limit, when we approach from the right, the limit as x approaches 4 from the right of f of x minus f of 4 over x minus 4 is positive. And we can work it out. So we're on this part of the branch, we're on this branch of a function now. You go up 1, you go over 4, so it's 1/4. So this is actually equal to 1/4. Okay, so I'm going to say, therefore, the limit as x approaches 4 of f of x minus f of 4 over x minus 4 does not exist. And that means that f prime of 4 does not exist. So f of x is not differentiable at x equals 4. Not differentiable at x equals 4. And we answered it. So we looked at the limit from the left. We looked at the limit from the right. They were not equal, so the limit overall doesn't exist. Since a derivative is a limit, you need the limit from the left to equal the limit from the right. Didn't happen in this case, so limit doesn't exist. F prime doesn't exist. Function's not differentiable at 4. It's actually differentiable everywhere else. It's only at 4 that it's not. So we would say this is not a differentiable function, but only because 4 has messed it up. Find the average rate of change. What is average rate of change? Say it with me, probably a lot of times. Average rate of change, algebra 1 slope. Algebra 1 slope, average rate of change. Average rate of change, algebra 1 slope. Comes up all the time, you have to know it. So we're just looking for the algebra 1 slope between -2 and 8, so that's gonna be f of 8 minus f of -2 over 8 minus -2. All right, we gotta go to, you know what I'm realizing here? I've used f every single time and the function is called g. Should I go back and change that? All right. Fill in. Oh boy. I use f a lot. A lot. All right, I'm gonna change it. I like to use red to highlight my errors. G, 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 G. I get to say GG a lot here. G, G. G, 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 oh my gosh, G. All right, finally, we're back. We're back to making new mistakes. All right, G of 8 is definitely 3. G of -2 is -1. And then the denominator here is 10. So we get 4 over 10, so I'm gonna write 2/5. So that is the average rate of change between x equals -2 and x equals 8. There's a place where it's not differentiable in the middle. So that's going to be interesting for us. Let's see. I almost just forgot that I'm doing it. I'm making these videos out of order for some stupid reason. So like it's really hard for me to remember what you do and don't know if you were going from like page 1 of notes 1 through whatever. But I really should be going in order. I don't know why I'm not. All right. Differentiability is a big deal. It seems stupid to highlight this. I'm going to highlight it anyway. It's a big deal. So we want to know what a graph will look like when it's not differentiable. And we want to know what it means if I tell you that something is differentiable, what does that imply about the graph, right? So there's two features that a graph can have where it's continuous but not differentiable. And the features are like really, really similar. And then there's a third feature that we can have where it doesn't look like these. But we can have what's called a cusp. So a cusp, let me tell you what technically a cusp is. If we look at this, the limit as x approaches, I'm going to say it's c. It's actually 0 for this particular function, so I guess I'll use 0 from the left of f prime of x, right? So what are the tangent lines doing? Imagine a tangent line on this thing moving from left to right. How is the slope changing? This is going to go to -infinity. There's nothing right about what I just drew. -infinity. Whereas on this side, the limit as x approaches 0 from the right of f prime, so the slopes of the tangent lines or the slope of the curve, think about that. You're going from right to left. How is the curve changing? How's the slope of the tangent line? It's going vertical, but it has a positive slope. That's where you're going to get a cusp. It's when the slope from one side is going to -infinity and the slope from the other side is going to positive infinity, or you could switch them and go positive infinity, -infinity, whatever. That gives you a cusp. A corner is a little bit different. You get finite numbers, but they are different. They don't need to have different signs. Like you could get the slope to the left is 3 and the slope to the right is 5. That would be a corner. So a corner is probably more common, honestly. But for you to get a corner, it really looks like a sharp turn. And you get, I really don't want to like write something down, but the slope from the left is finite. The slope from the right is finite. They're just not the same. They don't need to have opposite signs. They could have the same sign. So corners and cusps are definitely places that visually you can tell a function will not be differentiable, but will be continuous. So continuous, not differentiable. So in my experience on the AP exam, they never distinguish between these. I don't even think they really like use the words. Sometimes you are given a graph of the derivative and you're asked like to find the places where the function, or you're given a graph of a function rather, asked to identify places where the function is not differentiable. You can usually just say not differentiable at x equals 0 because there's a corner or a sharp turn, whatever. Keep those in mind. So those are two of the features. The next feature that you could have, and then I'm gonna like cut this video because I just realized I accidentally went to this page. Totally fine, I guess. The other feature you can have is this thing. Like what's happening there, right? So the thing that's happening there is that f of x, so this is actually called, this is a point of inflection. If you've done some like curve sketching at some point, curve is going from concave up to concave down at this kind of really interesting point here. So at this point, I'm going to say f of 0 exists. F prime of 0 does not exist, but, kind of covering that up, but in both cases, the limit as x approaches, I'm pretending this is at 0, just for simplicity. The limit as x approaches 0 of f prime of x is actually equal to infinity. So you get infinity from the left and infinity from the right. So you're going to get a point of inflection there. You get a vertical tangent line. Crazy. Vertical tangent lines are basically useless because you can't plug anything into them. But this is another way that you can be continuous, not differentiable. So the most common ways are up here, your cusps and your corners. You can also have this is kind of also the craziest of the points of inflection. where the curve goes vertical for one instant and then kind of like moves on with its life. So what I'm going to do is I'm going to stop here. I'm going to come back in the next video, finish page, whatever page I'm on, I guess page 4. I will see you then. So hope you're finding these helpful.